Hello friends, welcome again to the tetrahedron chemistry classes. So guys, in today's class I am going to discuss the numerical based on the Clark method or the soap titration method. In the last class I have explained you the principle involved in the Clark method, right, where I have explained you how to derive the expression for the total hardness, temporary hardness as well as for the permanent hardness. In today's class we will see the numerical. So first of all, let us take a look what the numerical is saying. See, the numerical is like that: estimate the different hardnesses present in the hard water sample from the following data in the soap titration method when 100 ml of the water is titrated with the soap solution, right? And the data is like that: standard hard water is having the concentration of this, that is 400 milligram per liter of calcium carbonate, right? And when you titrate this standard hard water against this soap solution, then 36.6 ml of soap solution is required by this standard hard water, and this is the process of the standardization, right? And as you know, when we do the standardization process, then this volume basically corresponds to the V1 ml, right? And your second is your total hardness, right? When you take the sample water, right, and that sample water actually consumes 18.6 ml of the soap solution for the formation of the lather. And you know, when you are calculating your total hardness, then this soap solution, the volume of this particular soap solution correspond to the V2 ml, right? So this is your V2 ml. See, in the third step, the permanent hardness, you know, when you are evaluating or you are going to determine the permanent hardness, that means your sample water which is boiled to remove the temporary hardness, and whatever you will get, then it will that water sample will have only the permanent hardness, as I have explained in my last lecture. Okay, so this boiled water actually requires 6.2 ml of the soap solution for the formation of the lather in the soap titration method, and you know this correspond to the V3 ml. And lastly, you can see here, this is your lather factor, which is 0.6 ml of the soap solution. That means lather factor means if you take the distilled water and that distilled water still forms lather actually, but it will also consume some amount of the soap, and that amount, that volume of the soap which is consumed by the distilled water, it is 0.6 ml, and you know this 0.6 ml is correspond to the V4 ml. So if I go back in my last class slide, then what you can see here, these are the three different formulas, right? For total hardness, you are V2 minus V4 divided by V1 minus V4 multiplied by 1000, and this is your in ppm. And then for permanent hardness, it is V3 minus V4, and for temporary hardness, it is V2 minus V3, and denominator is same in all the three cases, right? So my suggestion is that if you are watching this particular video for the first time and you don't have any idea about the soap titration method or the Clark method, so kindly watch my previous lecture, right? So here is the link at the right top corner which is flashing here. You can go through there, you can go through the link and learn the principle. First you learn the principle involved in it, only after that you will be able to understand the numerical, right? So now how to solve this particular problem I'm going to solve. Please focus here, and what you can do, you can solve this problem along with me so that you have you will have the better idea how to solve the problem. So first of all, you know what is given here. What is given here? So given data is like that. Given, I am writing SHW. SHW stands for standard water, standard hard water, and that standard hard water contains 400 milligram of hardness, which is of course calcium carbonate equivalent, milligram per liter of CaCO3. This is given in the question itself, right? Where it is given here, you see here 400 milligram per liter of the calcium carbonate is dissolved in the standard hard water. So its strength is given here. But you can see here in your question, actually you are calculating all the things for the 100 ml. That means the water sample for which you are going to evaluate the total hardness, temporary hardness, as well as the permanent hardness, that volume is only 100 ml. But here you have been given 1000 ml, right? So you have to, first of all, you have to make the calculation for the 100 ml. See, if your 1 liter, that is 1000 ml, contains the 400 milligram, right? And then of course your 100 ml will contain the 40 milligram. How to solve that? So this is given in the question itself, and what you can do, you can calculate this for the 100 ml, right? So what is given here? 1 liter or 1000 ml, right? And that standard hard water contains 400 milligram of CaCO3, right? There is no problem in that, right? What you have done, you have shifted this 1 liter here, that is 1000 ml, which contains the 400 milligram, right? And you have to calculate for the 100 ml. So 100 ml of water will contains, so I am writing contains here, of course, quite simple, 400 divided by 1000 multiplied by 100, 10 times, 10 fours of 40, that is 40, and it contains only 40 milligram of CaCO3. First of all, this step you need to do actually, right? Only after that you will be able to solve the particular problem. Okay, and one more thing, right? Now I am going to move further. Say, first of all, I am doing the calculation. See, if I go back and read the numerical here, in the first portion, standard hard water is given. That means process of standardization requires 36.6 ml of the soap solution. So in this particular step, I am going to do this standardization of the you know what is given here, 100 ml of standard hard water. Since I am doing the calculation for 100 ml, so I will take the 100 ml of the standard hard water, and this 100 ml of the standard hard water requires soap solution, how much? 36.6 ml. Please check whether it is correct or not. Here, standard hard water, right? It requires 36.6 ml. Okay, so and now one thing which you should remember always, in every determination, so I am writing here, in every determination or calculation, calculation, we need to subtract lather factor. Okay, this is something very, very important which you need to know. So when you do this, then therefore, since actually I am writing, since 100 ml of sample hard water requires soap solution 36.6 ml, therefore after making this necessary calculation of necessary subtraction of lather factor, it should be like that. Therefore 100 ml of SHW required soap solution equals to how much? 36.6 given here, and 0.6 is the lather factor. If I go back and check the value of the lather factor, it is given here. Lather factor is how much? 0.6 ml of soap solution. That means distilled water requires 0.6 ml of the soap solution for the formation of the lather. So this is your lather factor, and this value we need to subtract in every calculation, right? Or in every step involved in the calculation. Okay, so this will give you what? 36.0 ml, right, of soap solution. I hope there is no problem in that. Now this 36 ml actually, see this 36 ml, please remember this 36 ml is now equivalent to what? 100 ml of the standard hard water, and your 100 ml of standard hard water actually contains calcium how much? If you check here, 40 gram. 100 ml of standard hard water contains 40 milligram of the calcium, and here your 36 ml of the soap solution is corresponding to what? 100 ml of the standard hard water. So basically this 36 ml of soap solution is equivalent to how much? 40 milligram of CaCO3, right? And if you apply the unitary method, so 1 ml of the soap solution will require how much? 40 by 36 milligram of CaCO3, right? Basically, this is very important. I already told you, in every calculation involved in the water hardness calculations, we need to convert all the hardness causing substances into the calcium carbonate equivalent. Basically, it is the calcium carbonate equivalent. Now I am moving further, and if you go back, what you can see here, for the total hardness, right? That means your sample water, for which you have to estimate, for which you are going to estimate the water hardness, right? Total hardness. This sample water, or 100 ml of this sample water, right? 100 ml of this sample water requires 18.6 ml of the soap solutions. Now the calculation which I have done for the standardization of your soap solution, like that, now this the same calculation I'll do for this total hardness. The only difference is that in that case your 36.6 ml of soap solution is required, but in that case 18.6 ml of soap solution is required, right? So how to do the calculation? Again, it's quite simple here. So what you can do, 100 ml of sample water. Now you are having the sample water, for which you need to determine the water hardness, total hardness, right? 100 ml of sample water, sample hard water required. Soap solution, this is soap solution, that is equals to how much? 18.6 ml of soap solution, right? There is no problem in that. And in every step you need to incorporate, or you need to subtract rather, your lather factor. Your lather factor is what? 18.6 minus 0.6 ml, that is equals to what? 18.0 ml of soap solution, right? And since your hardness is calculated in the milligram per liter, that means you need to do this calculation for your 1000 ml, right? So for 1000 ml, first of all you will do for the 1 ml, apply the unitary method. I am doing one more step so that everyone can understand what we are doing actually. 18 divided by 100 ml of the soap solution. Generally we determine the hardness in the milligram per liter or the ppm. So it is we have to calculate for the 1000 ml. For 1000 ml you will have 18 by 100 multiplied by 1000. So it is 10 times. Here it is 180 ml of soap solution, right? Now in terms of calcium carbonate equivalent, in terms of CaCO3 equivalent, you need to incorporate that particular factor, which is your very important. In the last step I have done this thing. That means you need to multiply. If you want to convert that ml into the milligram of the calcium carbonate, so you need to multiply the factor with this value, 40 by 36, right? So what we will do here, this is your 180, and now you will multiply this with 40 divided by 36. Let us check whether it was, yes, it is what? 40 by 36. So once you do that, then automatically your result would be in the milligram of the calcium carbonate, right? So if you solve this particular factor, then what you get here, see, 9 4s are 36, so I am using the different color. 9 4s are 36 and 9 2s are 18, 20 times, right? And 4 10s are 40, and 20 into 10 equals to what? 200. So 200 mg of CaCO3, and it is present in which amount? 1000 ml. That means it is in this quantity, 200 mg per liter, which is same as 200 ppm. So your total hardness is 200 ppm. Now if you go back and check your question, then for permanent hardness the soap solution required is 6.2 ml. So the same calculation which I have done for the total hardness, which I have done for this standard hard water, right? That means that is for the standardization. Now the same type of thing we'll do for the as a permanent hardness also. The only difference is that in this case 6.2 ml of soap solution is required. So you need to subtract this lather factor, that which is your 0.6 from this 6.2, and then convert that into the calcium carbonate equivalent and calculate the thing for the 1000 ml. Then you will get your permanent hardness, right? Let us check how to do this. 100 ml of boiled water. If you boil the water in the open container, then temporary hardness will remove and you left with the only permanent hardness. So your 100 ml of the boiled water, which is having only the permanent hardness, it requires 6.2 ml of soap solution. But you need to subtract the lather factor from this. So what you will do, 6.2 minus 0.6, you need to subtract this value from here. That will give you 5.6 ml of soap solution, right? And this you need to calculate for the 1000 ml, because we need the answer in the milligram per liter, and 1 liter equals to 1000 ml. So we will calculate this for 1000 ml. So this will give you 5.6 over 100 multiplied by 1000, goes the 10 times, right? So it is 56 ml of soap solution. Now in terms of the CaCO3 equivalent, in terms of CaCO3 equivalent, how much it will be? 56 multiplied by 40 by 36. I hope this is quite clear to you. So if you do the calculation, so here if you cancel this by 4, so it is 4 9s are 36 and 4 10s are 40, and this will give you 560 over 9, and that is equals to what? 9 6 are 54, 2, 9 2s are 18, then further 2, 9 2s are 18, 62.2 mg of CaCO3 which is present in the 1 liter. So your answer is what? 62.2 milligram per liter or 62.2 ppm. This is your permanent hardness, right? And if you subtract the value, if you subtract the value of your if you subtract the value of the permanent hardness from the total hardness, then you will get your temporary hardness, right? So you need to calculate for the, you need to do the calculation for the temporary hardness also. So I am not doing that calculation. I am simply doing this thing. Total hardness equals to temporary hardness plus permanent hardness. So I am writing pH for this one. Your total hardness was 200, I think. Okay, and temporary you need to calculate, and your permanent hardness is 62.2 ppm. So your temporary hardness equals to, and then 62.2. So I'll write the 0.0 here. Then this is your 8, this is your 7, and then your 3, and then 137.8 ppm is your temporary hardness, right? So this is how you can calculate the temporary hardness, permanent hardness, as well as your total hardness by using the soap titration method or the your Clark method, right? If I go back, then think again, what is the use or the utility to remember or to mug these particular formula? These are of no use if you don't know how to convert your soap solution into the calcium carbonate equivalent. So this is the general idea about, this was the general idea about the derivations involved in the soap titration method. right? But these are hardly of any importance if you do the numerical problem. So my advice is that you need to go systematically and conceptually to solve the numerical problem, right? I hope this is clear to you. So that's it for today, and I'm signing out. Before signing out, I'm requesting you, if you are new here and watching the video for the first time, kindly subscribe the tetrahedron chemistry classes and do share with your friends also, so that everyone can get benefits from these particular video. Thank you very much.